Now we are going to see about the defects caused by the material. The first defect is discoloration. Discoloration is nothing but when a molded part is different color than intended. That means you can able to see the part should be in the white color, but some amount of yellow color patches has been appeared after removing from the mold. Right. So this is called as a discoloration. You can able to see this is the correct part and this is the defective one, right? But both the parts are new parts only, but the defect has been happened as in the terms of discoloration. The major cause of discoloration is left out palate in the hopper or residual resin in the nozzle or mold from the previous production run. That means you can able to see from this cause your complete mold cavity and the hopper has to be cleaned before going to the next process, because the hopper means you can able to say this is particularly for the injection molding, right? So it can be repeatedly happen in the injection molding. In the injection molding you can able to use different set of materials, right? So before changing the material you have to clean all the parts of the injection molding. So by doing that we can able to reduce, right? So ensure the work, or you can able to see the ensure the workers properly clean the hopper. There is no other any typical cause. Only by cleaning the hopper we can able to reduce this cause, right? And also clean the nozzle mold between the production runs. So you have to clean the mold for each production runs, so that you can able to reduce this discoloration. Next one is delamination. So delamination is a thin layer on the surface of a molded part or easily separated or peeled off the underlying material. So such kind of a defect is nothing but the delamination. This is nothing but how we are removing the our notebook or book, no. So page by page you will get, no. So such kind of a thing will be happen. So that is nothing but the delamination, right? So the major cause of this delamination is, the most common cause of delamination is contamination of a resin pellets, right? Or other base material with a foreign material. So any contamination or any foreign particles impinged in the mother material, right? So in such case the bonding would be happen properly, right? If it happens properly then it will get we can able to get a proper part. So if we don't have a proper bonding then it will leads for some delamination, then removing, right? So increase the mold temperature or pre-dye the material properly, we can able to reduce this delamination. And the next one is flash, right? So there are a small flap of a thin extra plastic, you can able to see, right, at the edges of the finished product. Okay, so this is called as a flash, spew or burst, right? So the major cause or a low cost mold that is not properly designed or that has been worn out due to the over usage, right? So as I said before, we will keep on use the mold for tons and tons numbers of plastic molding. So there will be some worn out, right? Due to some corrosion or some friction action, there will be some worn out. So the proper closing of a mold won't be happen properly, so that when we are pouring some molten material it will escape at the edges, right? So the next cause is very high mold temperature or pressure during the injection, right? So at very high force we are injecting the material into this, then it will try to escape at the edges, so that you can be able to have such kind of a defect. So the mold may not be redesigned, right? Due to its faulty one or worn out, we have to maintain that properly, and the temperature and the pressure have to be adjust according to the material what we are using. This is one of the typical defects in the plastic processing, is nothing but the gloss difference. So you know that some glassy surface will reflect a light very in a high intensity, whereas when the wood cannot able to reflect the light, so the shyness between the glass and the wood will vary, no. Such kind of a effect will also happen in the plastic processed parts, right? So gloss is a different reflecting property of a plastic molding. smoother the surface of a mold, the smaller scattering angle, right? So when we are having the rougher, so we will have a larger scattering angle. So whenever the surface is very rough, right, you can able to see some kind of a patchy over the surface, right? So this is due to different cooling conditions and shrinkage effects will happen. So more number of material will be accumulated in one surface, right? So that only it will have some kind of a rougher surface, right? So the cooling difference will be there, and so the shrinkage effect will be happen, so that we are going to get such kind of effect. And poor polishing of a mold, right? So that means foreign debris, or we cannot properly clean the material of a previously molded will be there. So such accumulation will make the gloss difference in the surface. What are the remedies means, if the part design allows to increase the polish of a mold surface, we can able to redesign the mold and clean the mold and increase the melting temperature will also able to reduce this shrinkage effect. And next we are going to see about the difference which is caused by the mold. The first one is short sun, right? This is also the same as the misrun as you have seen in the casting, right? Short occurs when the flow of molten material does not completely fill the cavity in a mold. So this results that the molded component is incompleted after cooling. You can able to see, so there will be incomplete. So what it means, so the filling, right? We are pouring some material. So due to the fast cooling of a material, it won't fill in this area, so that they will have a defect like this, right? So this area cannot be filled. You can able to see this is the area, it is not properly filled. Also you can able to see here, right? So the most common cause of a short is flow restriction resulting from narrow or blocked gate, right? So the grating system is not proper, it will lead for short sun. And sometimes the material is too viscous or the mold is too cold to allow the molten material to completely fill the mold before cooling, right? So if there is some difference between the viscosity of a mold or a cooling rate of a mold, then it leads for short kind of a defects. What are the remedies? Redesign the mold with wider channel or gates from the better flow, and also we can able to increase the mold temperature to prevent the material from cooling too rapidly. And the next one is flash. So flash is a common defect between the material and also due to the mold, but the cause is different. Cause and remedies are different. So the thing is same, there will be some extra materials which comes after the mold, right? So what are the cause which is related to the mold? A low cost mold that is not properly designed or that has been worn out, and also over usage, right? So very high mold temperature or pressure due to the injection molding will also causes the flashes. What are the remedies? We have to redesign or retool the molds if it is not properly fit together, right? So it has to be fit like this. It has to be properly fit. If it is not properly fit, there will be some mismatch, so that some amount of material will be splashed out of the material, splash out of the mold, right? So that it allows the material to flow outside of the channel, and also by increasing the plant clamping force to confine the material. So when we are increasing the clamping force, then the air gap or any such kind of defects can be closed, or else we can able to use a gasket between two molds to closely pack the mold cavity, so that it will restrict any excess material to come out of the mold, so that we can reduce this flash. And next one is silver streak. This is also something which is related to the gloss difference. So silver streaks can be described as a streaks of a silver or white in color in the finished product, right? In the finished product, that usually occurs in the direction of a material flow. When we are pouring the material, right, so it is flowing like this, then the silver streaks will be happen in the how the material is flowing over the mold. So the cause, These silver streaks are usually caused by excess water that is absorbed by the material. It could also be due to the contamination of a material with the foreign substances or air bubbles that are trapped inside. So you can able to see due to three different causes such defects can be happen. The first is excess water in the material one, and due to the contamination of a material, and also due to the air trapped inside the mold. So these three things will lead to silver streaks. How we can able to reduce means ensure that the mold is thoroughly cleaned before starting a new run, and pre-dry the raw material, and investigate any foreign contaminations was there in the material before getting into the process. This is nothing but a silver streak. And next one is product stuck in the mold, right? So this is occur when the finished product does not separated from the mold. You can able to see these are the mold. So few parts has been stuck in the mold itself, right? You can able to see here also, right? So why this is happening means the residual pressure of a mold is too high, and there is a shrinkage in the product, right? So that it is locked between the mold, and the mold draft is not larger. Okay, so the draft, that means we have seen there, no, the pattern draft, such kind of a thing not be proper here, and the mold finish is in a irregular angle. The finish has to be very smooth in a proper angle. If we are having some irregular angle, such kind of part strucking will be happen. So how we can rectify this means decrease the temperature and pressure setting could help to get the finished part unsucked, right? And also by increasing the size of the mold draft or redesigning the mold to have a better finish could prevent this product stuck in the mold, right? So generally if we redesign the mold, we can able to reduce the product stuck in the mold. So the next one is ejector marks and grooves. So ejector marks are the depressions or the elevations causing adopts changes in the wall thickness. This may also cause punches of the surface of the part. You can able to see, so such kind of a marks will be happen. So this is nothing but the ejector marks or the grooves. So what are the major cause means wrong dimensioning or the designing of a mold, premature demolding or high demolding forces, or wrong fitting or ejector length, right? If you are having a wrong fittings or wrong ejector length, you can able to have such kind of a defects. How we can able to reduce means check the counter bores and contact surface of the ejector pins. So where it is going to contact to the surface, we have to check, right? And change the ejector size accordingly. So it's the ejector size is should be 1 mm, means we supposed to have only 1 mm, right? Not beyond that. And reduce the demolding force if it is required to be high, or reduce the holding pressure of a mold. By doing this, we can able to easily reduce this ejector marks and the grooves. Coming to the summary, in this video we have seen about the various defects which was caused by the process, material and the mold.